Hello world, welcome to the next part of Game Dev the Hard Way. An ongoing series where some guy with questionable sanity and fashion sense builds a game from scratch for an obscure piece of hardware using just the C programming language. This is the third video, so if you're new, welcome. I'm trying to make a game for this device. It's called the Agon Lite. It's a single board retro-inspired computer that includes an EZ80 CPU and an ESP32. Normally you program this using BBC Basic, because it's kind of inspired by a BBC Micro from the 80s. But I found a C compiler that works on it, and I like C. So I figured it'd be fun to try and write a game completely from scratch using it, using the tools on my PC to cross-compile code to run on the piece of hardware. In previous videos, I got things drawn to the screen and I started writing some Sprite and physics code. In this video, we're actually doing a bit of game design, and then trying to make the beginning of a playable level where the player is able to move around a sort of game world made from tiles and interact with them. But enough waffling, let's actually get on with this. So in the first video, I asked for some game ideas, and I received quite a few in the comments of that video. And while I didn't pick a specific idea, I did get quite a lot of inspiration. I like the idea of the game not being a shooting game. I did originally say I wanted to make something that isn't a clone of existing games. So I'll take that feature somehow. Maybe the game can be more stealth and strategy based, like a few of you suggested. It might fit well with the limited hardware that I've got available as well. Actually, some commenters left pretty lengthy ideas. If that was you, go and install a game engine and learn how to use it. It's not actually that difficult. YouTube is full of lots of videos explaining how to use all the popular engines out there. You've clearly got some ideas that need to come out your brain. And you can do this stuff. It's not required to be like a decent programmer. Since I'm still lacking in imagination of my own, I had a bit of a conversation with everyone's favourite cheating tool, ChatGPT. And amongst the utter nonsense it came out with were a few interesting nuggets of wisdom. So, my vague kind of game concept is this. It's going to be a top-down, sci-fi themed game. The player is going to be exploring an abandoned, malfunctioning space station, trying to work out why it went wrong. There'll be traps of some description and obstacles to avoid and puzzles to solve and some sort of slightly deeper plot to it. Yes, I saw the latest Alien movie, just be quiet, ignore that, I wasn't inspired 100% by it. But the general gist is it's going to be something space research base has gone offline. You're an engineer sent up to investigate and repair the space station. Hand wavy waffle. The station's AI, because it's topical, has gone mad. You've got to repair droids that are malfunctioning and trying to repair you and destroy you and stuff. And you've got to avoid them and fix things and whatever. It's going to be a flick screen game. So instead of smoothly scrolling the level as you walk, the next part will appear as the player hits the edge of the screen. I don't think I'm accidentally remaking Zelda in space, or Gauntlet 2 in space, or cloning the 8-bit guy's pesky robots, but in space. But this style of game works well on restricted hardware. It's probably why there's so many games like this. And I like the idea of being able to create game mechanics that can be built up in fun ways. Making levels for Doom was something I enjoyed as a kid. The level design tools had a range of features from which I could build levels. And it was my imagination that led the way. I just sort of put walls and platforms and things together and see what happened. It was quite fun. It might not be an amazing idea, but who cares? It's the journey that's interesting, and it's a general direction to go. And I'm sure I'll change my mind after a week of trying to make something. It at least beats making moving squares around the screen, doesn't it? And talking of moving squares, let's replace those with some placeholder graphics, starting with the player. Which is a bit hard. I'm a programmer, not an artist, so my art skills are a bit limited, which is something I want to work on eventually somehow. Fortunately, other people far better than me have drawn sprites and put them online. There's several places you can find graphics. I can usually find something by digging around on itch.io. I managed to find this placeholder, and that'll do for now. But it only comes in 4 directions, not 8. So I guess the game won't have diagonal movements then, really. Because we don't call these problems, we call them design constraints. Since I have a load of Sprite code already written, and a Python tool to convert ACE Sprite images into my Sprite data, Getting this image into code was pretty easy. I should probably explain the code that makes the sprites work. The code to do this has evolved quite a bit. Here's the important part. If you remember from the last video, which you should totally go and watch if you've got no idea what's happening in this one, I had all the code for the player mashed into like the main C file. I've now split it off into its own separate file. I'm kind of copying what you do in C++. So this is the equivalent of some sort of constructor. It just returns a pointer to some nicely allocated memory that points to a C structure that contains all the data. This is the player's update function, and all it does is works out what key you're pressing and then decides how to use that based on like what direction to move in and also what direction you're facing. So this is how I store all the data about the sprite. So we've got its ID, we've got a position, we've got where it was last time, which we'll use later. We've got a pointer to what type of sprite it is, a pointer to where the physics lives, and then there's some other stuff that we'll get to when it's important. Once we've worked out what key we're pressing, we then have to set the behavior, which is just like which graphics animations we're showing. I use this lookup direction function, and all it does is works out from the vector that you're moving in which one of the 4 possible images we should be using. Once I've done that, we scale the vector for movement by some random value that feels nice in the code, and I tell the physics library to apply the force. Now, adding sprites changes the feel of what I'm making. I know fundamentally this is identical to moving a box, but now it looks like a little character, and it's somehow more engaging to interact with. The subtle but important difference created by how the screen looks is something I'll continue discovering as I progress in this project. Like, I've just incorporated new sprites in this, and if we run it, all I've done is swap the rectangles from last week to this random little guy thing that I found on the internet. But it immediately looks and feels much better than just a random square moving about. You know, there's something about the way the game looks that is quite important, obviously. At the start of the video, I mentioned I wanted the player to move around a space station. I guess I need some graphics for that too. And this is a classic case of assuming a task is more effort than it really is. I don't want to admit how much time I wasted trying to find a nice tile set before I realised I could draw something myself. It was about an hour and a half. I need a placeholder image that looks like a floor, and a placeholder image that looks like a piece of wall. I can draw that, it's rectangles, and you colour them in. It took like 2 minutes to do each one. It was easy. Just, you know. The Agon only has 64 colours. Finding the exact ones is a bit complex. Fortunately, Mike DX on the Agon and Console 8 community Discord server has helpfully created an Sprite palette file with the colours. I'll link to it somehow in the comments below. Having drawn some tiles that don't look too awful, the next step is to somehow load them into the Agon and draw a tile map. This is where we get to the actual meat of the video. Implementing a tile map system completely by hand, because we're doing this the hard way, remember. I found the tile editing tool, Tiled. It's a bit like Sprite, small, built to do just one task, and it exports its data in useful ways for programmers. I recently learned from one of your nice comments that Sprite was originally from the Allegro game engine library thing that was out in like the 90s and early 2000s on PC. I think it was an alternative to SDL, which is still going. So here you can see I've drawn out the map, and I've been able to put items on it, so I can say where the player is, where some enemy is, and where the exit is. Each one of these are objects, so I can give it like a name, and I've got its position. I can also define all the tiles, so I've got 3 of them here. And I can say what they are, like empty one, floor, and wall. Because all these tools are made for programmers, they're designed to do one job and that's it, and Tiled is just there for making tiles and tile maps. And it's got a few extra features that you would want as a tile designer and programmer, like the ability to add custom metadata to the maps that it generates. And it makes its files in a file format that I can parse. It produces XML, and here's what it does. It comes in 2 parts, so one part just defines what the map is, but then also all those items that are placed on it, so the player, the exit, and the enemy. And then there's another XML file that defines what image is used for the sort of tile map itself, and then what each tile is. So where I set it to be empty floor or wall, you can see it's appeared inside the XML as well. And because this is XML, it's really nice because I can parse that and turn it into my own custom data structure using some Python that I've written. This is the Python code I've written that parses the XML data. It's a little bit messy, there's lots of bits where I'm sort of directly pulling out parts of the XML structure. But generally it just seems to work fine. I gather like the file, the map width, the map height, the tile width, the tile height. I go through each file, working out the parts I need, and then I write it as bytes straight to an output file that I can use later. Some people seem confused how this is working and that by using Python I'm somehow cheating. I'm not handwriting the whole thing in assembly like people did in the 1980s. I have seen you in the comments and you are 100% correct. Writing in C is the easy way compared to handcrafted assembly that you used to do. Okay, I totally understand that. Because becoming better at assembly is something I want to do in the future. The thing is, the particular CPU I'm using is an EZ80, which is really a microcontroller. It's not a 1980s Zilog Z80. And all the documentation is aimed at people using the official Zilog C compiler and nothing else. They assume that because it's a microcontroller, you download their dev kit, which is Windows only, and you use that and nothing else. But I'm also paying attention. Writing a game in assembly does appeal to me, just not on this hardware. Maybe something more well documented. This video series is giving some of you flashbacks to that kind of thinking as well, isn't it? Because I've seen you in the comments as well. Don't worry, it's okay, we'll get through it. Still, at least we're not copying and pasting JavaScript and trying to make CSS line up neatly. So let's carry on, because the Python code, I'm just using it to make tools to process data. They're not running on the Agon, they run on my PC and produce data files that the Agon then uses. And let's look at a data file for the tile system for a minute to see what's inside it. So the way this works is all my data files start with a little magic string at the beginning so that I can check that I'm loading the right piece of data in. I'm then storing the map width and the map height of like the whole map. Then I store the tile width and the tile height. I'm then storing how many tiles I've got. That's the individual tile images. So in the previous example I've got 3. Which is also the same as the number of objects that I just happen to have. That's like the player and the enemy and the exit and stuff like that. I'm then making a list of this data structure, which looks like this. I'm storing like the name of the thing. So if it says player, or it says enemy, or exit, or whatever, I'm storing the name of that as a string. But because I need to read this in, I can't just keep reading until I hit 0 bytes or something. So I'm storing the length of the name first. Then I know how many bytes to read in for its name. Then 2 bytes for the X position, 2 bytes for the Y position. I'm then doing a similar thing for the types of tiles, where at the moment I just store the name of the thing like floor or wall or empty or anything else that I'm going to make up. So I need to know how long it's going to be and the length of the name. And that's it. I've then just got the map data, which is just all the bytes that describe the entire map. And that's map width by map height bytes long. So this is a little run through of the code that does that. So this bit on the screen at first just opens the file. If it can't find it, it just exits because I don't quite know what to do if I can't open the data file. I probably just need to quit. Then I read in what I call the file tag, looking for all individual letters. If I don't find that, again, I quit because I don't know what else to do. The next thing is to read in the rest of the header data. So I can read that all in as one go, as like a whole load of 10 bytes. That reads all those ones coloured white on the screen. What I can then do is allocate memory for the big list of map objects I'm about to read in. And then that's what this piece of code does. It's just a loop. And it says for each map object that there is, read in all the data. I could probably read this in like one go. But doing it like this, I can also read in each name because I need to know how long things are. But again, I should just better do that in like one read call. But anyway, this works. And then I do the same thing again for all the tile lists. I'm reading the screen too much. The type of tiles that I'm loading in. So floor, wall, whatever. C is quite good like this. Because a structure is just a contiguous piece of memory, you can read each individual thing either one by one, or if you know how long the entire structure is, the whole thing in one go. Makes reading data a lot easier because as you're about to see, loading the map data just involves allocating enough memory for the map and then doing one read of that size of data to read it all in. I'm then loading each tile image into the VDP so that the Agon knows what graphics I'm talking about. And that's pretty much it. Now, being able to make my own data files that store exactly what I want in a way that I can make use of is possibly the most useful skill I've developed so far. Once this data is loaded into the Agon, I can make use of it in a few different ways. I can use it to create all the objects for that level. For the moment, it just creates the player. The player's location is no longer hard-coded in the code. Not hard-coding data into things is one of the things I always try to do. If I can load a data file off storage, it means I can reload it later on. I don't have to quit the program or recompile or any of that other stuff that slows me down. So this is how I do that in the code. This is like the main loop for the game. So I have this first run function, which loads in the tilemap, and it stores it inside a test level structure. Then in the first... Okay, there's a mistake on the screen. 10 internet points if you can spot it. So anyway, after I've loaded the game first run, which is twice, I call game_init, and that just goes through every single object in the level, and for now, if it's a player, I create a new instance of the player. Later on, there'll be more things to work out, enemies and etc, so that will get bigger. I might figure out a better way of doing this, so that I don't have to manually choose every single one myself. I feel that if the game knows what objects are in the game, it should be able to do it by itself. That seems doable. But anyway, the end result is that it's possible to draw the tilemap on the screen pretty easily. So this is the code. All it is a nested for loop that goes through the entire width of the tilemap and the entire height of the tilemap, and then plots whatever image is required onto the screen one after the other. So it's as inefficient as it looks. When it runs, you'll notice that like the game slows down quite a lot. If I play the game without the tilemap, it's pretty quick, and you can see how like the character just moves around the screen and feels quite fluid and looks quite nice. But then if I turn on the tile drawing, it all grinds to a halt. So it's not that the player is moving slow, it's just it's taking so long to draw all these tiles on the screen, it can't do much else. It's not very satisfying, is it really? I don't think it's very optimal. But never mind, there's a bigger feature missing. I can probably speed this code up in the future. For now, I need to implement tile collisions with the tilemap so that walls are solid. This is actually a bit hard, because I've got a physics engine where each item has a collision box, and complex maths is done to make sure things are solid. Thing is, it's not intended for solid walls and floors. It's just intended for like things to bang against each other, like different players and bullets and stuff. I don't want to fill the physics engine with the hundreds of boxes stacked next to each other to describe the walls. Feels really inefficient. So instead, I had a bit of a think, and old games did this by simply testing whether the player was about to move into a tile space that contained a wall, and if so, you just put the player back at the edge of that tile. This might work if we can elegantly shoehorn that into our code somewhere. So this is the Sprite system update function, and I've added a new bit at the top, where it just checks if there's a tile map present. It then goes through each sprite that's actually being used, and we work out which tile is overlapping. We then go through all those tiles and find out by looking it up in the tile map whether it's a wall or not. If it is, we then call this physics resolve tile collision function. So this fun little function called physics resolve tile collision, it takes in the physics body and the current tile that you're talking about and its size, and it works out how much of the tile you're overlapping and then in which direction you need to move to not overlap the tile anymore. All this code should result in the beginnings of a pretty robust tile engine that handles sprite collisions. It's hard to describe how satisfying it is seeing this code working. There's nothing hard-coded in this, there's no like weird hacky rubbish. It is doing what it's supposed to do. I can change the layout of these tiles, I could redefine the colours and everything, and it would still work. Not only am I coding all this by hand the hard way using just C and deriving all the code by hand, I'm also engineering a system that isn't full of quick little hacks. I'm constantly trying to strike a balance between writing proper code and getting the code working. I decided it was worth doing this to make it work properly. There are other bits where I'll take shortcuts just to make it work, because I know it won't be as important. Like when I totally ignored the awful performance issues earlier. I think we need to go and fix those, don't you? But before that, I just want to say, if you're watching this video, thanks a lot for sticking around this long, because I know it's quite long and detailed, this thing. And I also know a lot of you watching don't actually have an Agon machine. You know, you haven't got, where have I put the thing? You haven't got one of these. You're just watching because you either like the process or, I don't know, it's quite cool. Tell me why you watch these videos, I'm curious. But it's nice to know you're choosing to spend your time watching this instead of whatever else is being recommended up the side of the screen. So if you're still listening, please interact with this video in some way just to let the almighty algorithm know that you're still there, because it helps all the, the crap that I need to do. Something I'm enjoying is seeing people leave comments and ask questions. I try to reply to them, but I think a better idea might be for me to create a Discord server or some other place to collect all these things together. Because I've got email, but it's being flooded by spam. It seems something quite odd happens if you have a YouTube channel and it gets to a certain size. It's also kind of amusing reading comments from people that are utterly confused about what's going on. I'm making a computer game for this thing, okay? Keep watching, it may make sense eventually, but I don't make any guarantees because I don't quite understand what I'm doing either. We're doing it for the shits and giggles and just for the fun of doing it. That's mostly why I'm here. So thanks for being here as well. Now strap in, because the next bit is a little bit deep. I've got a tile system that doesn't work very well, and how I made it work better is a little bit confusing. So what I've done is I've broken drawing the sprites into 3 parts. So what I do is I go through all the sprites that are active and visible, and the first thing I do is work out where they are on the screen, and where they were on the screen. I don't actually need to keep the new position in this bit. I can remove that piece of code. That's nice. So I just need to know where the sprite was in the frame before. And then all I do is I draw the copy of the background that we made last frame on top of where the sprite used to be to erase it. This really thrashed my head because the first time round this loop there isn't anywhere you were before. So trying to get my head to understand how this works was really confusing. I had to draw things on bits of paper and shuffle them around to understand it. But then the next loop works out where the sprite is going to be next, and we take a capture of that piece of screen. So we take a copy of whatever's on the screen at the moment before we put the sprite there, and we keep that safe. That's the thing that we draw at the end, well, the next frame around. Then, wherever the sprite is going to be, I actually just draw the sprite on the screen, and that's the last thing that we do. And that is how I do my dirty rectangle sprite drawing. The end result, though, is very, very satisfying. I can now move around, and I don't go through the walls, and the walls are solid, and I move at a decent speed, so this is all pretty cool. But it's still flashing. What's with the flashing sprite weirdness? I think it's time to use real hardware, so bear with me while I get the actual device working. Because I've got the code here, I just need to get it onto the Agon. So the first step is to actually compile it and install it on the SD card, which I can do with my makefile. Got this nice make inst SD. And all that does is compiles it and copies it to the SD card, and then also updates the Agon's autoexec.txt so that I can then just put the card in the Agon and turn it on. I don't have to type anything. First I need to remember to unmount the SD card though. And now I can take this out of here. We can find the Agon's impossibly small SD card slot. I then need to power the Agon on. Right, we're going hands-free for this bit, so ignore any wobbly. Right, so I'm reusing this monitor because I don't have any more. I've got 3, okay. I don't really want 4 just for an Agon, plus it's widescreen, it's all weird, but anyway. This monitor is bad. There's no buttons, there's no input controls. I just have to press the power button and then use the power button to cycle through the menu options. And when I let go, it then switches to the right input. But then I've got like half a second before it decides there's no input on there and it comes back. But I want to see the Agon boot up. So we're going to do this quite quick. So we do that. We plug its power in and it should boot up. Here we go. It's loading. Takes a while to load on the real hardware, doesn't it? And there we go. Oh crap. It's crashed. What now? This was literally working and now it isn't. Well, stay subscribed and we'll find out next time. See you later. Nah, bugger that. We're not doing that kind of video. Let's keep going. because if you look at what's on the screen, there's a hint about what's happening. If I get my shaky camera a bit further, you can see this text. It's printing out my debugging text. Okay, it's clearly loaded in a font. It knows what the font's name is. It's read in the name of the font, which is an 8x8 font, contains 80 characters starting at ID 2000. It's now trying to load a bitmap. This should be a file name. So we've got fonts, the folder, and then things go a little bit squiggly here. It's complete garbage. All the C programmers in the audience, are you currently shouting at your tellies and your phones, tell me why this is happening? So there's something wrong with this code. If you look at it, it seems to look fine, you know. I'm using the safe versions of all the string functions. So I'm using string copy and snprintf, so I don't run off the end of arrays. So if you didn't know, normal string copies, they just look for that null terminating byte, and if they don't find it, they keep looking until they find one, and probably go run off into memory, God knows where. The other thing with the new safer versions of these copies are if you're trying to copy more bytes into a string array than there is space, it will write up to the end of the string array and stop. What I didn't quite appreciate is what happens to the null terminating bytes. It doesn't write them at the end, it just copies enough bytes and then stops. It doesn't terminate the string for you. So string manipulation in C is painful, because all of this code is this stuff in Python, and that's it. I'm finding the dot, and I'm replacing the dot with 222, and some numbers afterwards, and that's it. And my problem is that I can't count, apparently, and I forgot how some of these low-level C functions work. So the fix was just to add one more character to each array, and then to actually null terminate it anyway. That's it, you know, allocate one more byte, whoopee-doo. That's it. C is such bullshit. Let's give this another go. Right, enough emulators, let's try it in the real hardware again. So, like before, we just type in make inst SD, does its compilation, and then it's copying it to the SD card, and it's copied. So now let's just get the camera set up so it's pointing at the screen, and then we'll see what happens. There's got to be a better way of getting the data off the computer and into the Agon without needing to fiddle with SD cards, because that's doing my head in. This memory card reader, I keep forgetting which way around to put the memory card and it gets stuck. Just annoying. Right, we'll plug it in, we'll press that, put it on VGA. I heard it beep. Okay, it's loading. Loading takes longer. I had to put loading bars on so I knew it hadn't crashed. Hey, we have the title screen. We have the level. It's working. Look at that. That's so awesome. It actually works. On the real hardware. And it's not flashing. The screen is stable. The little character, he's just there. He moves. He moves with a decent frame rate. It's not laggy and strange. This is perfect. Ignore the weird colour banding you can see. Like, this is not as purple as it is in real life. This is just the monitor. I told it was cheap. The camera viewing angle is terrible. But there we go. I'm well happy with that. This is getting somewhere. This feels game-like. So the next thing I need to work out is both things to do and a way to move on to another screen. So some sort of exit that when you walk through it, it then moves the screen out the way and the next screen appears. So I'm doing that kind of game. If you go off the top, I'm going to shunt the entire screen down, and then you'll appear at the bottom and the next level is here. That way I can do some sort of Zelda style scrolling of the level and not have to worry about frame rates of doing that whilst playing the game. Remember, we've got hardware that is not as fast as it like we're used to now. So we just have to work around that with clever ideas. They're not problems, they're challenges. I think that'll do for this video. Took a while to make this one, not because doing this was especially difficult. I mean, it was actually really, really hard, but it also only took a few days of actual effort to get it working. Because I knew what I wanted to do, I just had to figure out how to make it work on such a limited machine. No, the actual time-consuming part is when real life gets in the way. It's quite annoying. I mostly do this in my spare time. I'm gradually working out a routine that makes this sustainable. The next video will come out a bit sooner, but I want to introduce an idea I've shamelessly borrowed from the excellent channel Usagi Electric. You see, he's on a bit of a mad mission to build a Valve computer from scratch, but clearly encountered several issues or delays like you do when you build stuff. So rather than releasing one video whenever they came out, he decided to also take on another project, restoring an ancient mainframe computer. And when that became a bit too much, he then took on repairing a really old valve and diode based computer. I like the way he switches between projects, both to keep his own interests going, but it also makes his channel interesting to watch. Because everything's around the same basic idea, but it keeps things varied. So I've been thinking about what else I could do. And all the comments about, oh, this isn't the hard way, back in when I was a lad we had to hand code assembly by typing in the raw hex bytes after hand assembling our code on a piece of paper, has actually got me thinking. You see, my thing is understanding the low-level workings of computers. Knowing how this thing works internally is the interesting bit. The game is just a way of getting there. And I need to go and play with assembly. I want to get better at that. But I need a project to keep me focused. Otherwise I'll literally forget what I'm doing and I'll switch to something else without realising. Two things that appeal to me are old school DOS VGA programming, because I was a kid in the 90s, I've seen demos, they're pretty awesome, I've seen old games working. I want to know how that functions and do it myself. And then there's bare metal Raspberry Pi programming, because again that looks quite interesting. And both seem well documented and a bit more mainstream, as in there might be more than 6 other humans on the planet that know what I'm going on about. So it might be good for the bit of algorithm engagement rubbish. You see, I'm not giving up on this Agon stuff at all. We're still going with this. But I do want to mix things up and keep both myself interested and maybe get some more viewers as well. Both to make all them YouTube numbers go up, because it's quite satisfying watching that happen, to be honest with you. Anyone making videos that claims they aren't interested in their subscriber count is lying out their backsides to you. It is quite fun watching that graph get bigger. But also, if I write some DOS assembly code and it's complete garbage, I'm fairly sure there'll be people out there telling me just how garbage it is, and then I can learn and get better. So, if you're still here after all that random rambling, and any of that sounded interesting, please consider subscribing. Now, I'm off to work out how to make this Tilemap do multiple screens now. So, I'll see you in the next one. Goodbye. This thing controls my teleprompt, which is telling me what to say, because without the teleprompt, I'll go off on a tangent and all the wrong words come out. It's actually like one of these little 8-bit do controllers, and it talks to a very broken phone. In fact, this thing is my teleprompt. It's got a completely smashed screen. It's barely functional, but it's good enough to run a teleprompt program. So now you know, people that were interested in the comments. Bye-bye. Stop, you